All right, guys, the first thing I want to talk about is how to solve an equation with a fraction. This is all something you've probably learned before, but I want to make sure that we're okay looking at fractions. They should not scare you it shouldn't scare you to see a problem with a fraction in it, okay? So first off, we need to understand that this problem is saying 3/4 multiplied by x is 9, okay? So we know that when we're solving an equation, we need to do the opposite operation. So 3/4 times x, the opposite of that is division. So in order to separate the 3/4 and the x, we would need to divide out the 3/4. But something else we should know about fractions is that if we are dividing fractions, we are really multiplying by the reciprocal, meaning we're changing this division to multiplication and we're flipping over our fraction. So really, this problem is this, okay? So to avoid the step of having to flip everything, we're just going to go ahead and flip it to begin with. To get rid of 3/4 times x, I need to divide out the 3/4, but I know that with division, we are really multiplying by the reciprocal, okay? If I do it on the left side, I'm doing it so that everything will cancel out and I'm only left with x all by itself. But if I do it on that left side, I have to do it over on the right side. So I'm going to have 9 times 4/3. Whenever we multiply fractions, in this case, we're going to multiply straight across the top and straight across the bottom. Now, we can pretend that this 9 is over an imaginary 1 if you need to see the fraction. So the tops of these fractions are 9 times 4, which is 36, and 1 times 3, which is 3. And then we can do what is 36 divided by 3, which is 12. So in this case, x is 12. If I go back and I plug that in to check myself, I'm going to say, is 3/4 of 12 equal to 9? And it absolutely is. 3/4 times 12 is 36 over 4, which is 9. All right, I want to look at another problem that has a fraction in it, but this time we have a fraction with our variable as well as a constant, and then we have our equals 11, okay? So anytime you see this, you don't want to touch this variable piece. You don't want to touch this coefficient with this variable until very, very last. So you want to pretend like it's not even there, which means the first thing you're always going to do is to get rid of your constant. So if I'm going to get rid of a +3 and I want to take it off of this left side and move it over to the right side, you have to do the opposite. Opposite, opposite, opposite. I do not add 3 to both sides. I do the opposite, which is subtract 3 from both sides. The point in that is that a +3 and a -3 cancel each other out. They make 0. It makes it disappear. And that's the beauty of this. Now I'm left with 1/2 x equals 11 minus 3, which is 8. Now I have a problem that looks exactly like our previous problem. Remember that we said to get rid of a fraction multiplied by a variable, you need to divide out the fraction. I need to divide out 1/2. But when I divide fractions, really all I'm doing is multiplying by the reciprocal, so let's skip that step. Let's go ahead and let's multiply by the reciprocal. Let's do it over here as well. Reciprocal means to flip-flop the fraction, okay? So the whole reason, again, of doing this is to get this to cancel out, and you're left with x and only x all by itself. You want to know what x is, okay? We say, well, 8 times 2 over 1 is just 8 times 2, which is 16. Okay? Get rid of your constant first, divide out the fraction, which is really multiplying by the reciprocal. All right, we're still working with equations that have fractions within them and how to solve them. One of the biggest issues I see in class is looking at two extremely similar problems, but they should be solved very different ways. Okay, first of all, I have x over 4 minus 3 is 1. Okay, or I have x minus 3 over 4 is 1. These look very similar, and a lot of students think that they're the same, but they are definitely not the same, and they definitely cannot be solved the same way. Okay, so let's look at this one first. I notice that just my variable is in the fraction. I have x over 4. That's my fraction, and then I have what's called a constant left out beside the fraction. In this case, like we said previously, you will not touch this variable part until last. You need to address this constant piece first, okay? Which means in order to get this -3 off of the left and over to the right, we do the opposite. So we are going to add 3 to both sides. That's going to be our very, very first step. They cancel. I get x over 4 equals 1 plus 3, which is 4. Now, some of you can do this in your head. You're saying to yourself, what divided by 4 is 4? Some of you may need to actually see the step worked out, and there's nothing wrong with that. The second step to this process is going to say, well, x divided by 4. In order to get rid of that 4, I need to do the opposite. And if this is division, the opposite would be to multiply. So if this is x divide by 4, we want to multiply by 4, and we would have to do that to both sides. The reason for that is that this is going to cancel, leaving me only x on that left side, and 4 times 4 is 16. Okay, I can go back and I can check my work, and I can say 16 divided by 4 is 4, minus 3 is 1. And go back and I can plug it in. Now the problem over here is going to be solved very different. This problem says that the whole entire left side of the equation is over some denominator. That means I have to get rid of that denominator first. I cannot mess with this 3 because the 3 is over 4. I cannot mess with this x because the x is over 4, which means 4 is my issue here. I need to get rid of the 4 first and foremost. Okay? So if this is saying x minus 3 divided by 4, I want to do the opposite of that, which is to multiply by 4 on both sides. Okay, the whole reason for that is to get rid of the fact that there is a fraction. Now you're going to see how simple this problem is with x minus 3 equals 1 times 4, which is 4. This leaves me with an extremely simple problem. It makes life so much easier. I'm going to do the opposite operation to get x all along. So I take my -3 and I add it to both sides. That's going to leave me x equals 7. Again, I can take that 7, I can go back and plug it in. 7 minus 3 is 4, and 4 divided by 4 is 1. So I know that it worked. All right, here's another problem that looks similar to the one we just did. You've got your whole entire left side of the equation over a fraction. The difference here is that I've got an outside number, I've got some parentheses, so eventually I may have to distribute, but we're going to start this problem the exact same way. I can't touch the 2, I can't touch the x, and I can't touch the 4 because they're all over top of the 3. So I need to get rid of the fact that this left side is a fraction. So if this is 2 times x plus 4 divided by 3, I'm going to do the opposite of that to get rid of the 3, which means I'm going to multiply both of these sides by 3. Okay? Those are going to cancel, leaving me 2 parentheses x plus 4 equals 12 times 3 is 36. Okay? Most of us know that when we see parentheses, we need to distribute, so that's what we're going to do next. We're going to say 2 times x is 2x, and 2 times 4 is 8 equals 36, and then we can continue to solve from here. We'll subtract 8 from both sides, and we'll get 2x equals 28. So we'll see that x equals 14. Now here's a problem where we have our fraction inside of the parentheses over on the left-hand side. Okay? This is kind of a combination of all the problems we've done together so far. you have more than one way to solve this problem. I'm going to show you what students typically do, then I'm going to show you a little bit of a shortcut. So typically we see parentheses, we know we need to distribute. So we're going to say, well, what is 2 times x over 3? I like to come down and write my fractions out so I can see what I'm doing. 2 times x over 3, well, that is 2x over 3. I multiply 2 times the x, I pretend like there's a 1, 1 times the 3 is 3. I get 2x over 3, okay? So then I'm going to do my 2 times my 4, and that's going to be plus 8 equals 12. Okay, I don't really need this. This is just where I showed my work, so I'm going to get rid of that. Now I've got a problem very similar to what we did earlier. I've kind of gotten rid of those parentheses. It doesn't look near as hard now. Remember, I do not touch the part that involves my variable until very, very last, which means I need to get rid of this 8 first and foremost, okay? So if this is a positive 8, to move it off this side and over to the other side, I'm going to do the opposite by subtracting 8. And I'm going to get 2x over 3 is equal to 4. Now I have one of these problems where I've got a fraction. The whole thing is over 3, which means I will need to get rid of the 3. So I'm going to change back to black so you can kind of see my steps here. I need to multiply both of these sides by 3 so that I have 2x equals 12. And then hopefully you know that from there, x is going to be equal to 6. Okay? This is the first way to solve this problem. This is what most of us would typically do. And there's nothing wrong with that. If you distributed, that's perfect. That's what you've learned to do in the past. I am going to show you a shortcut that will save you a step. Okay, let's get rid of these arrows. If my whole entire left side is being multiplied by 2, then why don't we just get rid of that 2? If it's happening to the whole left side, then it's perfectly okay. If I want to get rid of the fact that 2 is being multiplied by everything, I'm going to divide out the 2. I'm going to do it on both sides, because what I do to one side, I have to do the other. Okay? This is saying 2 times all of this stuff. The opposite would be division, so it goes away. And I end up with x over 3 plus 4, which is what's inside of those parentheses, is equal to 12 over 2, which is 6. From here, you're going to solve this exactly the way that we did a couple problems ago. You're going to get rid of this constant first by subtracting 4 on both sides. X over 3 is going to be equal to 2. So to get rid of this divided by 2, I'm going to multiply both sides, or divided by 3. I'm going to multiply both sides by 3. And I'm going to get that x equals 6, which is exactly the same answer that I just got previously. So it doesn't matter which way you do these problems, they will work. The biggest way to check yourself, the best way to check yourself is to take this 6 and plug it back in. 6 over 3 is 2, plus 4 is 6, times 2 is 12. So we know that we did it correctly. Thanks so much for watching this video. I hope it helped you learn something about math, or at least made the problems a little bit easier for you. Stay tuned. Make sure you hit the subscribe button. I'll be coming out with more math lessons all year long.